Hi students, today we are discussing the topic minimum cost spanning tree. First of all, we need to define what is spanning tree. Spanning tree is a subset of graph G. Graph consists of vertices and edges. That's why we have to denote graph G of V comma E. Okay, this is one of the example of graph G, A to B, B to C, C to A. Here, what is the spanning tree? Spanning tree is a subset of a graph like this. Like this manner, look at this diagram. A to B, B to C, C to A is not the connection. It is one of the subset of graph G. Spanning tree is a subset of graph G which has all vertices covered with minimum possible number of edges, which has all vertices are covered with minimum possible number of edges. Hence, a spanning tree does not have a cycle. Hence, spanning tree does not have a cycle and it cannot be disconnected. Cycle in the sense if you want to form the entire edges in a graph, that is nothing but one loop. Okay, loop will be formed there, but spanning tree does not have a cycle and it cannot be disconnected. Here one more subset, A to C, C to B. Here look at this diagram. Here graph consists of A to B, B to C, C to A. Now we have to convert it as a spanning tree. Spanning tree is a subset of graph G which has all vertices are covered with minimum possible number of edges. Minimum possible number of edges. So hence spanning tree does not have a cycle and it cannot be disconnected. Look at this. Here we have to be C connected A to C, C to B, A to B, B to C, and now we have to be A to B, A to C. That's enough. No need to connection between B to C. Here weight of spanning tree W of T is the sum of weights of all edges in a tree T. Okay, here look at this. Weight of spanning tree is the sum of weights of all edges in a tree. Here look at this. A to B, how much edge will get come the how much weight of this edge 1. Here coming to look at C, A to C, how much the weight of edge of A to C 2. Here we need to sum of weights of all edges in a tree. 1 plus 2, that is nothing but a 3. Here we need to study about a minimum spanning tree. Minimum cost spanning tree is a spanning tree with the smallest possible weights of all the edges. Okay, listen carefully. Minimum spanning tree is a spanning tree with the smallest possible weights. Weighted graph G. Here weighted graph G. Look at this graph. I have give some vertices and edges. This is not a directed graph. This is only I have given the edges between the nodes. Okay, let us take. I give 1, 2, 3, 4, 5, 6. Minimum spanning tree from weighted graph. We don't want to. It doesn't form a cycle. Okay, here if you have to see, if you have to form fourth edge, loop will be formed. If you want to form fifth edge, loop will be formed. Okay, minimum spanning tree, it is a spanning tree is a subset of graph G which has all vertices are covered with the minimum possible number of edges. A spanning tree does not form a cycle. That's why here look at this. You doesn't minimum spanning tree from weighted graph 1 plus 2 plus 3. How much? 6. Example here. Minimum spanning tree can be used in design of networks. Okay, if you need to design one network, you need a minimum spanning tree. It can be used to design a network. Mainly it is based on least cost path with no cycles. Mainly it will be based on least cost path with no cycles. And second point, minimum spanning tree finding airline routes. We need to find out airline routes. It can be used for the purpose of minimum spanning tree. Here vertices represents cities, edges represents routes between cities. It is one of the example of a minimum spanning tree. Now in minimum spanning tree it can be constructed by using two algorithms. First one is Kruskals algorithm, a second one is Prim's algorithm. In Kruskals algorithm it is mainly uses edges for constructing or we can determining the minimum spanning tree. It is mainly uses edges. In Kruskals algorithm it is mainly uses edges. Listen carefully, it is mainly uses edges for constructing purpose of the minimum spanning tree. Coming to the Prim's algorithm, it is mainly uses vertex. It is mainly uses vertex for constructing the minimum spanning tree. Now we see one of the best example of Kruskals algorithm, and later we discuss Prim's algorithm. First of all, we need to take one example of Kruskals algorithm. This is the example diagram of Kruskals algorithm. We need to follow one algorithm. Based on that algorithm, we need to perform the operation of that particular problem. Okay, first step in algorithm, remove all loops and parallel edges. Yes, exactly. In this diagram, if we have one loop, see if we have S, A, B, C, D, T is there. Okay, now see how loop. That's why the first step what have to say, the first step what we want to say, loop, remove all loops. C loop will be eliminated, and parallel edges. Here we look at A to B. A to B how much? 6. A to B 9. This is nothing but a parallel edge. We need to remove a parallel edge based on the minimum cost. If we have to take minimum cost, least cost path we need to select it. Maximum cost we want to eliminate it, and parallel edge also eliminated. Listen carefully. Remove all loops and parallel edges and write down the diagram remaining part. And step 2, you need to arrange all edges in their increasing order of their weights. Yes, increasing order of their weights in the sense, if we have to take for example 2, after 2 the increasing order will be 3, after 3 the increasing order will be 4, after 4 the increasing order will be 5, and then 6, then 7, and then finally 8. Okay, this is the increasing order of weights. We want to arranging all edges in their increasing order of their weights. First of all, if you have to look at the increasing order of their weight, first of all, if you have to take BD how much? If you need BD 2, and then DT 2, AC 3, CD, look at this, CD how much? Edge weight 3, CB 4, BT 5, AB 6, SA 7, SC 8. Next we want to study about the step 3. Add the edges which has least weightage. Okay, if you need to add the edge which has least weightage. Look at this, B to D is least weightage 2, and D to T least weightage 2. Next cost is 3. Next the least weightage is 3. Next cost is 3. The edges are AC and CD. Yes. Here AC, if we have to take A to C 3 and C to D how much? 3. Yes, correct. Next least cost weightage is 4. The edge is CB. C to B, if we have to put C to B, a loop will be formed. That's why it's a closed circuit will be formed. That's why I want to be discarded that CD weight cost. Okay, and then I have to select BT 5. Next cost is 5. If I select 5, closed loop will be formed. That's why I discarded. Why? Because of, look at this, 5bt is 5b to t. I have a b to t, closed circuit will be formed. That's why I will be discarded. Next cost is 6 a comma b. Ignore 6 also. Why? Because of loop will be formed. If you take a to b, the loop will be formed. That's why I will discard that. Next cost is 7 comma 8. 7, the edge is 7. Yes, a, yes, a, yes is there. If you have to write down s to a, 7. Okay, and then if you have to take next cost is 8. 8 s to t, s to c, 8 next cost is 8. 8 s to c, the loop will be formed. That's why I discard that value 8. Okay, a comma s, least cost path selected. Okay, the edge is a comma s is 8. If you will be formed this loop, that's why the closed loop will be formed. That's why I will be discarded that eighth edge also, A to C. So this is the minimum spanning tree of Kruskals algorithm. By using Kruskals algorithm, the minimum spanning tree is completed. This is the concept of Kruskals algorithm. No need to form a cycle, no need to form a loop, no need to form a closed loop, closed circuit. Okay, loop or cycle or closed circuit or closed loop, these are all only one name. Here in minimum spanning tree, we don't want to form a loop. Okay, this is the concept of Kruskals algorithm. In the next video, we will discuss Prim's algorithm. Okay, up to in Prim's algorithm, what is the main purpose of Prim's algorithm? It is mainly uses vertex. It is mainly uses vertex. Thank you, ma. If you have any doubts regarding the topic of minimum cost spanning tree, can you please ask me? Thank you.